If you want to learn C++ or you are interested in it, you are at the right place. I started programming with the beginning of this channel. Use the timestamps for a better overview by hovering over the time bar, and not to forget, if you like the content and want to be part of the future community, consider to subscribe and leave a like. And with this, let's start the video. And today we are looking into 3 chapters, the 1.6 until 1.8. First we look into undefined variables and those undefined behaviors, and then we go into keywords and how we can name the identifier of them. Then we'll also look into the whitespace like space, tab and enter, and the basic formatting, how you should format your code that it is readable. Today we start with the new chapter, initialized variables and undefined behaviors. And in this chapter they just want to say that don't use initialized variables because they can make so many errors. And here we have a simple example that it is not declared, and some compilers can make a random number out of this when there is not a warning that the variable is undefined. So for this example it gives a number that is displayed here, and for Visual Studios this does not happen. We have a little go around for this example to show what happens when we don't define it, and we go to that now. Here we have a little function integrated that just takes a number or the integer x, puts it in the function and returns it directly, but it has no value at all. And that means it just takes the memory space, looks at it, it's nothing there, and returns it back, and there is no value. And when we run it now, it just gives it a random value. And for this example we have minus this number that is displayed. And it can be really annoying when some bugs like this happen. And for example, when we remove the function here and we run it now, it does not work because on Visual Studio it recognizes initialized local variable x used, but this depends on which level you have your warnings in the settings. And now we can go here to undefined behaviors. If you have some problems because you have an initialized variable, it can happen basically everything. That's why he gives such a big warning and makes a separate chapter for this, because it can happen so much if you do that. So if you have a variable to define them directly, otherwise you will have problems without a doubt. And here there's an example for how many bits are in the in a variable, but it's not for now. And then we come to the quiz time for this section, and it asks us what is an initialized variable, why should we avoid them. And yeah, it's basically what I just said. An initialized variable is just a variable that has no value given to it, and it gives a value by itself, just a random value. Sometimes it matters how the compiler is set up, and using the variable stored in an initialized variable will result in undefined behavior. So it could happen basically everything with this variable. And what is undefined behavior and what can happen if you do something that exhibits undefined behavior? It can happen basically everything, and that's what it says here too. Probably undefined behavior is a result of executing code whose behavior is not well defined by the language. The result can be almost anything, including something that behaves correctly. And yeah, it can happen everything. So really don't make undefined variables, otherwise you have your errors programmed in your code. And now we go directly to the next chapter, and I think the other one is clear, that you don't use undefined variables And this topic here is keywords and naming identifiers. Here we have the most used keywords, or basically every keyword that it is used here in the C++ language. And they say we almost look in every single keyword in this learncpp.com platform, and you will have the knowledge of almost every one of them if you go through with me or by yourself on this website. And now we go to the identifier naming rules, and the identifier cannot be a keyword, so it cannot be the name of one of those keywords that we see here. Then another rule is it can only be lower uppercase numbers and the underscore sign. The other signs will not work in an identifier to go to identify these keywords. And then the identifier must begin with a letter and cannot start with a number. This is the other one. Otherwise it cannot say if it's an identifier. And this is all set or defined by the compiler. And then we have the last one, the C++ keys sensitive, thus distinguish between lower and uppercase letters. N value is different than N value because they look into each letter, and if you have one letter different, it looks at this like another value. And when you have the value completely with uppercase letters, most of the time you will learn that later, that you have, in this case, you have a constant value, so a value that cannot change. This is why you make all the letters uppercase in this case. And now we are coming to identifier naming best practices. And here we have just some basic examples that we have to follow, because it's way easier if you follow them to read your code later. Here, for example, we have an example for the identifier. We want to write it all lowercase and not like the other example, first uppercase or the whole uppercase or whatever else, just all small letters. And there are some more examples like here that you can also do. You can do, if you have multiple names in it, my variable name with underscores in between, that's completely fine. And for the variable name, you should always start with a lowercase at the start. And if you have additional descriptions for your variable, you can do that in a start with an uppercase and then the rest is a lowercase. And the third example, this does not work because you cannot make a space for a variable. And the last one is not correct because you have the first letter big, and you should not do that, that your code is better readable. And then we have some more examples to show you which one is good or bad. Here the first one is a bad one because we have an C that is just, we don't know why you have put there a C, it's just there, and so you don't know what it does. Then we have customer count, that's perfect, you know what you want, you have the customer and you count them, so you know almost exactly what it does, so it's good. Then we have an I, you basically don't know what it is, but if it's a trivial example, or you have it just for a simple use, it's okay, you can use that. But if you want to know what it really does, don't use I. It's not, if you want to read your code in 3 months, you want to know what it does. And if it's really a trivial use case, you can use it, but otherwise not. And that is also for the other one, for the index. You could also call the I index, but you still don't know what this index exactly does. And here we have total score. This works as well, but also the same case that you don't really know which score, it's total score, but from what is it the total score, it could be confusing in your later code. And then we have here an underscore count. You should not do the underscore at the beginning of the variable because the compiler uses some variables that start with an underscore and it could cause issues. Then we have just count. It's again, what are you counting? You don't know. It could be everything. Then data, the same thing. Time, also the same thing. Minutes elapsed. That's actually good because you know that the value is minutes and how many have passed, and then you know what it actually is. And then we have value 1, value 2. Yeah, it's very difficult to differentiate which value is what. You better name it that it is clear which values you mean. Then we have num apples. That's very clear. You want to count the apples. Monsters killed. That's also very clear that you know which monster you have killed or how many. And then x and y. Again, you can use them if it's very trivial, and you just import the numbers to this specific location and return them, but not for big changing numbers. It's not a good practice because it's very confusing. And then we have here the quiz time. We go through again through what is good, what is not. And here we have this. We can assume obvious that we are summing, then this is actually okay. This is conventional. Int apples, you should not begin with underscore. Yes, and then we have value. You should not do all the letters uppercase except you have a constant. We will probably go later into that. My variable name, this is not correct. It will not work. Invalid. Int total customers, that is not good because the beginning letter is uppercase and it could be confusing. And then we have int void. You can actually not use that because it's a keyword for functions. And here we have an integer numFruits. That's actually good. You can use that. And now we have integer 3sum, and you cannot do that because it is a number at the beginning, and this is invalid for the compiler. And then we have int meters of pipe, and this is actually conventional. You can use that. And that's it for this chapter. And now we are going into the third topic today, whitespace and basic formatting. It is basically that we have spaces, tabs, and new line with the enter that we can use to make our code looks better. And we have some places that we actually have to use spaces that the code actually works. For example, here if we create a variable, we cannot put the x directly next to integer because it would change our type. So we have to make a space in between so that it can work. The same for functions. It will not work for that as well if you do that. And you can make as much spaces as you want if you write it correctly. You can leave all those spaces empty and it will work fine, or you could even make an enter to make a new line and it will work completely fine. And the next one is that you have to look that you put the comment only in the line that you wanted, or otherwise you make multiple comments. For the libraries, you have to make one line for each library, otherwise the compiler cannot know it if you want that. And now we have the quoted texts. Here this is normal text like hello world, but you could also write it differently. If you write it like this, you will have a big space in between hello and world, and you can also write it different. For example, here in this example it's correct. If you make a new line, you have to put each word in a double quote, and then on the next line you put the word in another double quote, so it knows it still connects to the std cout and it can print it out, and it prints the normal hello world like you would expect it, just with a new line. You have just to remember that you have to make a new double quote for it if you make a space or whatever you make for space in between. And using Whitespace for format code, you want your code that it looks very or not confusing, that you can read it better. So you better not do all the code in one line. You want the code that it is less compact, and this one is much more readable, but to make it even more readable you can change it to that what you see here, and following is even better. And you can even split some more. You can even put the hello world on a new line or whatever. Just find a style that suits you well, that everyone, when he wants to read your code, can understand as well. And now we are coming to formatting, and I just want to say that you have to find a way that is good for you, how to write your code, that you have a good overview, and that all other people that read your code can read it as well. So there are some forms that you can read your form. Here we have the Google style, that you have your curly bracket on the same line like the function, and the other one, the preferred one in this case, that you take your curly brackets a line downwards. And now there are multiple ways to make your formatting better. For example, if you have your couts, just make it like this, and then you can optimize them. For example, if they're too long, you can make a break and put them on a new line, so you don't get over 80 lines. There are some plugins where you can use that says you are over 80 lines, and then you can make a new line. And here, for example, are new ones with variables. You can put the values on the same line, so it is better. For example, here, that it is you have a much better overview like that. And now for the comments, for example, just put them all in one line, so you have a much better overview, and don't do the comments directly over it. Make a space in between, so it's much better readable. And all that formatting is needed that your code will be readable and for you better to understand and find your stuff. And this is very important, that you have a very good overview. And here, when working on an existing project, be consistent with whatever style has already been adopted. So don't just go into a project and use your own style. Try to use the style that is already used, so you have it consistent in the project. Otherwise you have to rethink the formatting style, and it could be confusing. And we have here an automatic formatting that is by default enabled by Visual Studios, and code blocks have one implemented that automatically corrects it when it's needed. And yeah, that's basically it for this section. Just look that you have a good and readable code for yourself that you can use, and try to adopt or yourself to other code that you are using. And yeah, that's it for today. In the next lesson we go further into introduction to literals and operators, and introduction to expressions, and maybe also developing your first program. And we have an additional chapter with the summary and some quizzes that we maybe also go into. And with this, that's the end of the video. I hope you enjoyed it or learned something while watching it, and With this, I say bye.